beginner friendly. Have you written Python before? Okay, so Python is a popular programming language, right? It's an high level programming language that is widely used across different domains, right? Python is used in data analytics, Python is used in data science, Python is used in software development and software engineers. I mean, they use Python for backend infrastructure of some popular software, backend infrastructure like Fast API, REST API, Django, right? Also Flask API. So Python is really is multi-purpose, right? And you can never max out the the usage of Python as far as the programming language is concerned because it is used across a whole lot of domains, right? And it's also known for its simplicity, readability, and extensive range of libraries that make it a powerful tool for data analysis tasks, right? I could remember personally when I was applying for a job during my, I think that was during my, when my studies year was about to start. Yeah. So I was applying for a job then that I could be doing alongside my service. So I had knowledge about all the SQL, Power BI, right? SQL, Power BI, and Excel. And the guy was like, "Do I know how to work with Python?" And I said, "No." And he said, "I'm going to need it." So that's why I decided to like study Python. Because seriously, in the world that we are today, there are limits to what conventional software can handle in terms of data crunching or data analysis. And Python as a software is very very powerful in handling big data. So when we talk about big data, I guess I have told you that big data can be they are characterized by three V's, right? They are characterized by velocity, volume, and variance, right? Volume in the sense that they can be very, very voluminous. Then velocity in the sense that not all data are static. Some data are being fed from streams, right? Maybe you are connecting to YouTube API or Spotify API, for an instance. Some data are not static; they are connected to maybe data streams that feed in live data, right? And when you talk about variant, of course, data can occur in multiple variants, right? They can occur in structured data, which are of course, tabular in nature, and they can occur in unstructured data, right? Which can be videos, images, music, audio rather, or Parquet, JSON, any forms of data at all. So Python is known for one to be able to handle big data, regardless of its volume, the variance, or the velocity. And also, by understanding how Python works, you are able to like leverage its capabilities for data analytics tasks, right? It is very, very powerful. So I think that's it. So regardless of how voluminous your data is, Python is going to handle it. So in this topic, we are just going to go through the fundamental concepts, the control flow statements, the types of data functions, and now apply Python on in handling real world data set, right? So if you are programming for a, if you're writing code for the first time, it can be a little bit intimidating, but it is learnable, right? It is pretty much, you know, learnable. I won't say it is simple because I mean, if you are writing code for the first time, empathize it. I think it is learnable. So, so we are just going to start with this. So if you are trying to, so this is how the interface is. This is the code interface. This is the text. If you want to add a code or you want to add a text, so you have this. So you can simply press Control Enter to run any cell, right? Control S Enter is simply going to run the cell, and I'm going to see. So if you want to print anything, you print with you print with you know print you print with let's say you want to print hello world for an instance, right? Print like that. So so this is just to tell you that to print anything at all, in some other software, let's say like MATLAB, to print you would probably use fprintf, then open brackets, put whatever you want to print inside the bracket, then print. But for Python, it is pretty much straightforward. You just have to write your print statement and put whatever you want to print inside the bracket. Then you print. I don't think there's anything complex about that. So printing is just a way of, you know, it's just a way of outputting whatever your computation or whatever your program might have churned out. So we are going to be seeing in the next couple of examples how printing really allows you to just output something that might possibly be saved in your piece in your what's it called in your program. Because there are some program you write that if you don't print it to just be saved in there. So printing just really ensures that this thing is outputted, like this thing is, shown at the end of the day. So this is print hello world. So this is another so this is another thing to note. So this notebook is prepared in such a way that you can always go back to, you know, see the you can always go back to read whatever is in there and see the content, right? So these are like variables and data types. I think we discussed these a little in SQL. So we have we have this name equals John, right? You can see name equals John. So if you say name equals John, or you say name equals Zinat, and you store that as a variable. So variable are just things that can, possibly change. Say x equal to 2, y equals 3, what is x plus y? So that's like variables. X and y are variable in that case. So variables are just, they are usually um, the key and the value, right? Something that is storing the other one. So for instance, this name is storing Zenat. So I can just simply say um, print name. I'm going to have Zenat. So this is a string, right? This is a string. Whenever you want to pass in a string inside Python, you use quotation marks, right? This is an integer, age equals 25. It's an integer. Integers are basically numbers, right? This is a boolean. So we have different, they are just two booleans, right? They are just two booleans, which can be true or false, right? We also have float. Let's say height equals 16.4, right? So you also have height, you also have float. So float are basically decimals, right? Float are basically decimals. And what other data types do we have? I think those are like the popular data types, and you can simply just print them like this. So John 25 through 16.4, right? So that's it. So this is a string, this is an integer, this is a boolean, this is a float. So another thing to know is that Python can be used for arithmetic operations, right? You can have, so if you want to insert a cell below, you can simply press escape and press B. So B is going to insert a cell below. If you want to insert a cell above, you press escape and you press A. A is going to insert a cell above, right? So you can use it to perform arithmetic operations, right? Let's say you are trying to calculate something. Let's say you have something like, let's say, area of a triangle, right? Or let's do something that is more relevant. Say it's something that you calculate day in, day out. Okay, let's use interest, some simple interest for an instance. So simple interest is usually PRT over 100, right? So you can have your P to be 100,000. You have R to be 5. You have T to be 3, right? So if you want to store this, you just press Control, Enter, and you from there you can find your interest. your I is equal to P, right? Your R is supposed to be PRT over 100, right? Which is going to, if you are going to be writing that, that's going to be, open bracket, you know, P multiplied by R multiplied by T, right? Everything divided by 100, right? So that's like the arithmetic operation. But it's not going to bring it unless you print, right? Print I, right? So I is 15,000, right? We will still like talk more on how you can print for more detailed output. So this is just showing that Python can be used for arithmetic operations, right? Simple arithmetic operations, and they are like different operators, right? That these work with. We have asterisk. We have one would have thought if you want to write multiplication, you use the times sign, but programming does not work that way. So it's asterisk. And if you want to add something up, you want to put addition, you put plus, right? And if it is minus, minus. If it is, well, we are still like going to get there where we talk about arithmetic operators. Then this is this cell is the arithmetic operations, right? So A is equal to 10, B is equal to 5. So if you want to sum, use A plus B, difference A minus B, product A multiplied by B, right? And quotient A divided by B. Right? So that's how it pretty much works. And another thing is that you have to you have to like know what operator is fit for this. For instance, if you have this division is different from having this floor division, which is this, right? So we already know. Let's have this in another cell. So all of these space that we write code are called cells, right? They are called cells. They are called cells. Then this one is going to be this. So if you print sum, you have 15, right? Print difference, you have 5. Print product, print quotient, quotient,
2.0, right? So what's quotient telling you? Quotient is simply about normal division, right? That's quotient, right? It would have been more interesting if the number is not perfectly divisible, which I'm going to be showing. So now let's print floor division. Print floor division. Floor division is 2, right? So quotient is just the number of times that a number can successfully go through, right, in another number. I just like the old way of dividing in primary school where you have 2 into root of, let's say, 10. So it's just, or 5 into root of 10. So it's just the number of times that a particular item is going to like go through in another item, right? Quotient of, let's say, 3 divided by 2 is 1, right? It will not tell you that, oh, it cannot go. Yeah, it's going to like divide it and be like 1 is the quotient, right? Quotient of 5 divided by 3 is still 1. 7 divided by 3 is 2. It's just like the number of times that an item can, you know, go through successfully in another figure. While floor division is, simply dividing it thoroughly. So let's say I have something like this: 5 and floor division of 2. So you have 2 there. But if you say 5 divided by 2, you have 2.5. Right, so this is pure division. Why? This is floor division. So another one is percentage, which is like remainder. Some items are not in that your notebook, so you might want to like update it as I am writing it here. Remainder. So the remainder is going to be a percentage b, right? So remainder is simply how much is left after division, right? Print the remainder. Zero, that is, divide 10 by 2, how much is left? So that is 0, right? So these are just like the basic arithmetic operators that you might be needing, right? Sum, which is plus, difference, which is minus, product, which is star, quotient or pure division, which is single slash, floor division, which is double hash, and remainder, which is the percentage sign. So those are the operators that you might be needing when carrying out any arithmetic operation. And it is also important to know the rules of naming a variable in Python.
So when you are naming a variable in Python, the cases are sensitive, right? They are case sensitive. So they are case sensitive, right? If you say, let's look at this. You say rise equals 4. Why am I using rise? What is this thing? Let's just use anything. Age equals 4. And say print age. Yeah, so you know this is the data that been specified above, right? Which was 25. But this is age. It doesn't register it as as the one you are printing, because starting with capital letter is different from starting with small letter. So case is a is a big issue in Python. It is case sensitive. And another rule is you do not define a variable without with a space. It's not going to accept it. You can't define a variable with space. It doesn't collect space. My my space equals 32. So it's not going to accept it. It's going to be invalid syntax. Python doesn't allow spaces in variable names. Rather, you are going to put underscore, right? Most programming languages do not accept space, by the way. You still have to put underscore. So I think those are pretty much about arithmetic operations and how basic syntax work, how they work. So you might want to do deep dive in all of these by yourself, but I mean those are the basic things on arithmetic operations and arithmetic operations and you know variables. So let's get to the next thing. So this is simply printing the data types, right? So there are different types of data, right? Like we have said, there's float, there's string, there's boolean, there is integer, there is date, right? Just like when you were working with Power BI, that you had to ensure that all the data points are valid. It is also important in Python to ensure that all the data are in the correct format, right? Whether it is date, it is an integer, whether it's date, it is an integer, or it is a boolean, or it is a float. So it is important that all the data sets are in the correct data forms when you are starting out. And you can check that with the types. let's say we have all these the variables that we defined earlier. The variables that we defined earlier. Let's say you want to say name dot d type. This is the types is used for tabular data. So you can just check type.
So let's print whatever that is. So it's telling us that that's a string. So let's print whatever height is. It's telling us that's a float. Let's print whatever the student is. It's telling us that's a colon. So all of these data types, are just there to let you know what you are into, especially if you are going to be working with real life data set. You want to be sure that all the data handling are in the correct data types or data forms before you carry on with your analysis. So it is that important to know what your data types are. And moving on, it is also essential, the difference. So I think we've worked with all these. So don't let us overplug it. Let's just move on. So we have loops. There's for loops. There's while loop. But before we talk about loops, it is important to know about you know conditional statements. I think we used conditional statements in both Excel and Power BI when you are trying to specify what happens when a particular condition is met or not. Take for an instance, group you want to group total scores by students into different grades.
So you say, oh, 70 to 100 is A, 60 to 70 is B, 50 to 60 is C, and so on and so forth. Those are the use of a conditional statement. They help in defining certain threshold to which a condition holds or not. So you have this. So these are just data types, right? So this is a simple example of how a conditional statement work. So you have A is equal to 10, and we say that if A greater than if A greater than 5, right? So this is a loop already. If A greater than 5 prints yes, it's greater than 5, else. It's not greater. So this is indentation, right? This indentation. This is indentation. So this space that we leave here is indentation, right? It's just you know controls the structure of your loop. Contains this. It controls the structure of your loop. If you get the indentation wrong, it might not give you the proper output. But that's not the point you know of this loop. The point of this loop is just to show how conditional statements work. So as you can see, we say that a is equal to 10. We define the variable as a is equal to 10. And we said if the variable we defined is greater than 5, it should print yes, it's greater than 5. Else, it should print it's not greater than 5. And here we go. It's greater than 5. Right? Do you understand, or do you have any comments? Yes, we are still in the easy part. So, or do you have any comments or any questions so far? Yes, if you don't get the indentation right, it's going to print something else. Let's say for an instance,
Are you typing this on your computer or you're watching? So let's say just put it like this. You see, it's going to throw an error. And what's the error? Expected an indented block after if statement. So, but by default, after like defining the condition, if a greater than 5, right, and you put a colon, that is, you want to specify what the output is going to be if the condition holds. I press enter, right? You are going to see what the output is going to be, right? Print this. Else, if it is this, even if you don't get this indentation right, I just, it could have been like this if I just press enter. Could have been like this, and I press run. So it's still going to like give an error, right? So it is important to get the indentation right. Right. Well, uh, if you are like writing code is people don't use hand to write code these days, but then I recommend you stretch your mental muscle when you are just starting out. Yeah, people don't use hand to write code anymore. Personally, I don't. People use AI. I mean, but if you are just starting out, I recommend. I'm going to share you a book, right, that you can read further to make a deep dive into Python. But people don't use that to write code anymore these days. We have to do this, right? We are covering Python as a course. So just get your indentation right and your loop is going to work. So after putting the colon, um, it gives an indentation automatically, and you are going to just, you know take a step back to tell it that you are now out of the loop by pressing backspace, and it should just print whatever after that, whatever you want to print after that. Then a list is this. So what's it saying? Hello, true. So I don't think there's supposed to be comma here. That's the problem. What's the issue? Oh, that's the issue. I thought it is thing on my screen. So there are different types of data types. We've got, I think we still are going to talk more about loop. Alright. So I don't want us to get carried away. Um, the what's it called? The curriculum is meant to be Python for data science only, right? So let me just share this portion. So this is the book I'm talking about. So let's just go through uh, the flow structure. So can you see my screen? So this is the flow chart telling you what to do if it is raining. So we call this loop. It's also like the pictorial representation of what loop is. So you start and you have like a condition. Is it is raining? If the answer is yes, then it proceeds to another loop. That is, you have an umbrella. If the answer is no, you wait for a while so that rain does not beat you, right? And if the answer is yes, that is, you have an umbrella, you go outside, then end, right? And if it is raining, and if it is not raining at all, you go outside, then end, right? And if it is raining, you don't have an umbrella, you wait for a while, right? And it is no more raining, you go outside, then end. So loop are just like, they are the fundamentals of structural programming, in the sense that they help you just create functions. They are great at creating reusable functions, right? That's the essence of loop, especially when you are dealing with more advanced data science or operations. Sometimes you need to like create reusable functions, and loop can help you with that. It can just compress everything. Instead of every time you come across a question of is it raining, yes, have an umbrella, no. Instead of having to like deal with that every point in time in your programming exercise, or in the problem you are trying to solve. Instead of having to deal with that every time, you can just create a loop in form of a function, right? You can create a function in form of a loop rather, that is going to be executing this whenever you are faced with that problem. So it's just the way of systemizing what's it called, a solution to a problem, so that it is reusable at every point in time. And we are still going to talk on functions, but then it is important to understand how loop works before talking about functions. So in a flowchart, there is usually more than one way to go from the start to end. This is the same. This is true for lines of code in a computer program. Flowcharts represent its branching points with diamonds, while the other steps are represented with rectangles, right? So I think I've explained that. So Boolean values are simply, they are simply true or false. Boolean values are simply true or false. And this is how you compare booleans. I think we touched on this when we are doing SQL operators, right? Except for equal to. So equal to is different from equal to, right? So this is a boolean, is a comparison operator, right? And it is used in conditions, right? So if you see a single equal to, that means you are assigning a value to a variable. Age equals so. But if you see a double equal to, that means you are in a loop. If a is equal to 2, so that is a loop. While when you have a single equal to, that is an assignment, right? You are trying to ask. So it might be asked that what's the difference between single equal to sign and double equal to sign, right? You can't just say you want to assign a variable with a value and just put a is equal to 2. Now it doesn't work. It doesn't work that way. So let me just demonstrate. Do you get what I mean, or should I demonstrate it? Um, let me get so. And this is not equal to. This is less than. This is greater than. This is less than or equal to. This is greater than or equal to. Right. These are these guys work pretty much. And yeah, I think I've explained this. The difference between the double equal to and single equal to operators. So a double equal to operator asks whether two values are the same as each other, right? It is used for a condition or a loop, while the single equal to operator puts a value on the right into the variable on the left. That is, a is equal to 2 or whatever the case may be. So we also have some operators like or and right. I think I explained what or and are when we also did SQL. Or is simply if either of the condition holds, while and is whether there's like an intersection between both conditions, right? If you use or, then you should expect the code to execute if either of the conditions are true, while if you use and, to only execute if both of the conditions, right, are true. So this is a what's it called? This is a flow chart that checks whether somebody's name is Alice, right? If name equals Alice, print hi Alice. I think this is not why I'm here. This is not the exact part I'm going to. I mean, you can go through all of this later by yourself. So now functions, there are different types of functions in Python. Let me go back to my screen. There are different types of functions, right? Um, let's say you have a list. You have a list which is let's say even numbers. So the even numbers are two, three, four. Ah, sorry, two, four, six, 8, 10. Let's say these are the even numbers. So you can have functions that is like sum even numbers, right? You can have a function that is like length of even numbers, right? Length is simply, how many items are in there. That is not going to work. So, so the essence of this demonstration is just to show that there are inbuilt functions and there are functions that you can define yourself. So this sum, length, let's say mean. Let's say you want to find the mean. I think mean is still mean now. The average. Mean is not defined. Now where are the statistics not working? Now, 1 second. Okay, I mean, okay, I see that main is an attribute of a numpy of the numpy library, and not for it's an attribute of the numpy library, and not for just general, and not just for general, um, and not just for general items, right? So, but NumPy is just a different library on its own that allows you to turn regular list into arrays. So NumPy is like merging numerical Python. It allows you to structure your data in a way that is suitable for some mathematical operation. Let's say you have this particular even numbers for an instance, and if you say mean even numbers, that's not going to work. But if the even number has been converted to a numpy array, say you have np dot you know np dot array, and you put the what's it called, you put even numbers in there. Okay, I have to import it first. um this was supposed to be more structured than this. So you have to import numpy before you can use it. Then you have this.
Then can now use can now use the numpy library cmp dot. Can name this my array. So this means the mean uh, is 6. The mean of those items is 6. Well, this is just like a digression anyway. The whole point is just to show that the what's it called? There are input functions, right? There are input functions, and also you can create your own functions. So input functions are like names that are like reserved in Python. You cannot even use them as a variable name. Uh, they are they are just they are just names that are reserved for specific operations in Python. Functions like sum, functions like length, functions like you know mean and other functions like type that we just like we used the other period, right? Functions like you can even out of the even numbers we can have mean minimum of even numbers is going to be 2. At the same time, we can have the maximum. So that is how all these work. And for every function, whether it is an input function or a function you created by yourself, for every function there's always an argument. So an argument is that value that you put in, right? An argument is the value you put in that you make it process, right? An argument is that value you put in that you make it process. So in this case, the function is mean, the argument is even numbers. So in this case as well, the function is max and the argument is even numbers. Here also the function is sum and the argument is even numbers, right? And if you are using length is simply telling how many items are there in the data, whatever that you do. So and there you have it. So these are functions and arguments, right? So you can also create your own function, right? So that is exactly where I'm going. You are allowed to create your own function. So inbuilt functions, there are different inbuilt functions. So just to add, Google Colab saves your notebook automatically since you are working with the cloud, just like working on Google Doc or any Google application or Google spreadsheet. It saves your code automatically. So I just want to like give a list of inbuilt functions you might find handy in your computation, right? So and what they do in Markdown, I think you wrote some Markdown in your GitHub, right? When you are working with GitHub, did you write the Markdown manually? So when writing Markdown, there are like rules in writing Markdown. Markdown are the same everywhere, whether you are writing it in GitHub or you are writing in VS Code or you are writing. So in your typical notebook that you use in writing code in Python, there is the cell for code, there's a cell for text, right? You see the beginning of the notebook. All of these are not code, right? All of these are like text, right? That are readable, that you don't have to run and get some value below the cell. All of these are simply code, right? So these folks they design notebooks in such a way that it allows for readability, so that even if somebody that is not technical is reading your code, they can have an idea of what is going on. So I'm just going to like put a text here to just cite some examples of functions and what they do. So we have the print function, right? Print function, which essentially displays an displays output. So you can even like insert a bullet in the text. E.g. print. And you have input. Takes user input. It's like so and so on and so forth. You might have another function as int So this simply like convert whatever to integer, right? Convert to integer. You have float, convert whatever to float, convert to float, right? So let's say number is in integer before you want to convert to float. Let's say 2 for an instance. 2 plainly is an integer, but when you convert to float, it becomes 2.0, right? So these are just functions, and we have tuple, which creates a tuple. We are going to be talking about tuple later on in data structures. Tuple creates a tuple. We have dict create a dictionary. We have branch, which is more like range of. We have any, which just returns true if any element is true, and of course we have a minimum and maximum. There's also sum, which we had demonstrated before. There's also sum, right? So that's it. So these are all inbuilt functions, right? And inside those brackets, right, Python is expecting something. It's expecting an argument, right? You see, this is the markdown. Let me put the title as input function. So in markdown, the higher the number of your hash, the smaller the text inbuilt functions in Python. So if I want the text to be smaller, I put another hash, right? Just like that. If you want it to be super big, you put it there. Then if you want it to be bold, you can make it bold over here, or you can just use asterisk. If you want it to be italic, you use underscore, just like you are writing in WhatsApp. But that's not the one. So these are the popular input functions and what they do, right? And like I said, every function expect an argument in it. Every function expects an argument in it. Say sum is expecting an argument that is even numbers. Already covered this. Can we say float? I think float works with single arguments, but let's see. Yeah, like I said, float works with single arguments. Float of 2 is 2.0, right? Wow, float of, wow, say int converts 3.2 to an integer, it is 3, right? So every of these guys expect an argument in them. So this understanding would help you, you know, help you like build the foundation of how to create your own functions, right? As we are moving on, how to create your own functions. So you know the structure of the conventional structure of a function, and you also know the conventional structure of a control flow or a control structure, a loop essentially, which is being defined by a conditional statement, right? I think this is where we talked about loops. I mean, let me embolden it. Conditional statement. So functions and loops, conditional statement, functions just allows you to be able to create your own functions and even make you able to do some OOP, object oriented programming, which is not the focus of the course for now anyway. So let me quickly introduce another loop. So we said this is for you know to print if something is greater than 5. So let's say you want to write a program for detecting even numbers, even num- even number. So that's going to be, let's say for detecting a or an even number. So let's say we've already known that that particular even number, say x, is equal to 8, and yeah, we can just simply say, you know, if x, how do you recognize an even number? An even number is a number that is divisible by 2, right? Without any remainder. So you are going to be using particular this particular remainder, right? This particular remainder division, that is, if you divide it by 2 and and the remainder is 0, that means it is even, right? Otherwise, it is odd. So if x is equal to zero, so you will not use equal to here, right? It has to be double equal to. If x, you know, remainder division by 2 is equal to 0, then print x this number is an even number. Oh, this is a Python word. Okay, let's put it in. It has to be put in quotation mark. Is an even number else is an so it's saying this is an even number. So the whole point of this is to explain, how loop or function works in their various minimal state, and it also to show how you can create functions, right? Of course, print is the function here, and this is the argument, right? And we've also demonstrated how functions and arguments work. Now, what if these inbuilt functions, right, that we've just explained? So now, what if instead of using inbuilt functions, you want to define your own function? So that's like the concept of user defined user defined functions in Python, right? And they normally follow this structure, which is normally follow this structure. What's happening? So they normally follow the structure def whatever function name the argument inside the argument can be arguments, right? Then you now define, of course, there will be an indentation. Then you now define the function definition, which is usually conditions. Usually conditions, and then print answer. Right. So this is usually how user defined functions, how they work. So I'm still going to, you know, I'm still going to show a proper code of how they work. So now let's say you want to define a function that works with area of a triangle. For an instance, it can just be define, or area of a rectangle, define area. Inside the area, of course, they are going to have two arguments, which is length and breadth. And ultimately, that is going to be A multiplied by B, simply, right? And after that, just print, or let's say we just make this C. So you just print C is the area of a rectangle of